I have taken a sheet of paper in my hand. If I want, it is possible for me to tear into small pieces. And again, if I want, it is possible for me to make it into powder with the help of a grinder. That means those powder particles of this paper combined together to give me this sheet of paper, right? That means everything that you see around you is composed of minute particles. And those minute particles which combine together to give me this sheet of paper or anything is known as constituent particle. So those constituent particles combine together to give us this sheet of paper. So this sheet of paper can be called as a matter. Not only this sheet of paper, anything that you see around you, whether it is a pen, pencil, my human body, your body, everything that you see around you is can be considered as a matter. Also, as you can see, this sheet of paper has a certain mass. If I place it in my hand, it occupies almost 3 by 4th of my hand. That means this paper has certain mass and it is occupying a certain space. So matter can be defined as anything that has mass and occupies space can be called as a matter. Now, you know that you are very familiar with the sand particles that you see in the beaches. Actually, those sand particles are the constituent particles of large mountains. In the ancient times, there were large mountains, and due to climatic changes, those large mountains eventually become large rocks, and those rocks, while flowing through rivers, they collide with each other, and also due to certain climatic conditions, they become pebbles. And those pebbles, again due to changes by colliding with each other, ultimately takes the form of the sand that you see in the beaches and the desert. That means this sand can be called as the constituent particle of this mountain. Also, you may be familiar with the chalk that you use to write in the board. This chalk can be broken into pieces, and this broken pieces can be crushed into powder. So that powdered chalk can be called as the constituent particle of this stick chalk. Also, while you analyze the form of the of the chalk before and after crushing, their properties remains the same. It is white in color before and after crushing. That means its properties remain the same. That means the chalk has undergone a physical change. If there was any change in its properties, we may say that the chalk has undergone a chemical change. But here there is no such change, so we can say the chalk has undergone a physical change only. Now, here I told you the powdered pieces or the powdered particles of this paper combine together to give me this sheet of paper. That means there is something that holds these minute particles or the constituent particles together to give us this sheet of paper, and that force of attraction that holds the constituent particles of a matter together is known as interparticle attraction. Now, here as you can see, I have shown you a pictorial representation of how minute particles are arranged in every matter. Whatever the size of the minute particle is, whatever small it is, then also there will be some space in between the constituent particle of every matter. And the space in between the constituent particle of matter is known as interparticle space. Now consider, in a beaker I have taken some water. You know that water is also a matter. As I told you, everything that you see around you is matter. So water is also a matter composed of H2O molecule. And to that water, I have added some sugar particles and I stirred with the help of a glass rod. That means the sugar getting dissolved in this water. Now, after complete dissolution of the sugar in this water, it will be appearing like this. And if I taste a solution from here, from this beaker, I will feel the sweetness of sugar. But as you can see here, no sugar particles is visible for you. That is, the solid sugar particle get completely disappeared, but we can feel the taste of sugar in it. That means here sugar is there, but the sugar is invisible. That means because as I told you, water is a matter, so definitely there is interparticle spacing in between the constituent particle of water. This sugar take the place, or the sugar get accommodated in the interparticle spacing of water, and that is why it is not possible for us to see sugar particle here, but still we can feel the taste of sugar. So we can say that interparticle space of water is occupied by sugar.